Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if technology could actually help you meditate better, maybe even reach those deeper levels of mindfulness people talk about? Well, today we're diving into a fascinating new look at how neurofeedback, a kind of brain training, might team up with meditation. The big question here is, can this technology actually help us on our meditation journey? Researchers wanted to see how neurofeedback, which uses real-time brain signals to guide you, works with different meditation styles. They looked at studies in both people who have mental health challenges and those who are just casually practicing. So right off the bat, the scientists found that this area of research called NF-Med neurofeedback assisted meditation is still pretty new. There are a lot of different ways people are doing these studies, which makes it tough to compare them and see exactly what works. It is like trying to figure out the best recipe when everyone is using different ingredients and cooking times. Now, why is this even important? Meditation, when practiced deeply, can lead to really amazing things like profound peace, self-awareness, and even insights into reality. But even though more and more people are meditating, maybe even 10% growth in participation of mediation and mindfulness programs in the US alone between 2002 and 2022, finding effective ways to guide people, especially beginners, is a challenge. Many people give up within the first month, and that is where technology like neurofeedback comes in. The idea is that by seeing your brain activity in real time, you can learn to direct it in a way that supports your meditation. Maybe it can make it easier for beginners, keep people motivated by showing them their progress, or even help experienced meditators explore more advanced states. But before this study, nobody had really gathered all the research together to get a clear picture of what is actually being done with neurofeedback and meditation. Previous reviews were either not very thorough or only focused on things like reducing stress, not on how it helps with the actual development of meditation skills. So, this paper is a big step in mapping out this new field. The researchers did a systematic search for studies looking at neurofeedback and meditation together. They looked through a bunch of scientific databases for anything that fit their criteria. They were looking for actual studies where people used neurofeedback while they were meditating. They kept their definition of meditation pretty broad, basically meaning focused attention on your inner experience. They excluded things like just relaxation techniques or studies that didn't use brain feedback. They also excluded studies using commercial neurofeedback devices where the technology wasn't fully explained. After all their searching and filtering, they ended up with 31 studies, which included data from about 837 people. Most of the studies they analyzed were done in the last 10 years. About 12 of them involved people with clinical conditions like schizophrenia or anxiety disorders. They looked at how much meditation experience people had. Some were complete beginners, others had practiced for thousands of hours over many years. The most common types of meditation studied were focused attention, where you concentrate on one thing and noting, or insight meditation, where you observe your experiences without judgment. For focused attention, people often focus on their breath, but sometimes on things like a computer screen displaying their brain activity. Noting meditation was often used with people facing mental health challenges, where the goal was to label thoughts and feelings as they came and went. Most studies tried to have a control group, either people who meditated without neurofeedback or a mock neurofeedback group. This is important to see if the neurofeedback itself is making a difference. They checked for changes in behavior, what people subjectively felt and experienced, and their brain activity. A really common target in the brain was what is called the default mode network, or DMN. This network is often active when we're thinking about ourselves or our past and future. Many studies aim to reduce activity in this network, as less DMN activity is often seen in experienced meditators. For studies using EEG, which measures electrical activity on the scalp, they often looked at the alpha and theta brainwaves, which are linked to states of relaxation and focus. So, let's look at what they found. For experienced long-term meditators, neurofeedback seemed to reliably reflect states of being more effortlessly aware. For example, studies targeting the posterior cingulate cortex, part of the DMN, showed that when this area was less active, meditators reported feeling more relaxed and focused. But here is a catch. It's not totally clear if these results are just for experienced practitioners or if they'd work for beginners too. When they looked at beginners, the results were more mixed. Generally, beginners could learn to control their brain activity during the neurofeedback training. However, they often couldn't take that skill out of the lab and into their daily lives. The changes in their behavior and how they felt weren't always consistent. For example, one study showed beginners could change brain activity, but it didn't really stick, and it didn't lead to much change in their mindfulness scores. They also looked at adolescents and found that while their brain activity could be modulated with neurofeedback, these effects didn't always transfer to other situations, and self-reported feelings of well-being didn't change much. Moving on to the clinical groups, they found some interesting, though still preliminary, results. Studies involving people with schizophrenia use neurofeedback to try and reduce auditory hallucinations by modulating brain networks. Some of these studies showed improvements, but the results weren't perfectly consistent. And the studies had limitations like only having one neurofeedback session for individuals with anxiety disorders. Neurofeedback combined with meditation did seem to help reduce anxiety and increase mindfulness. One study found that changes in the default mode network correlated with improvements in mindfulness. Another study looked at adolescents who had experienced early life adversity. They found that neurofeedback helped downregulate a specific brain area called the PCC and improve positive affect and reduce perceived stress, though the effects on mindfulness weren't always lasting. And in the study on obesity, neurofeedback combined with meditation showed improvements in weight loss, emotional eating, anxiety, and depression. After 3 months, but this study also had limitations like a small sample size and lack of control groups. So, what's the big picture here? The discussion section really drives home that this field is still in its early days. Most of the studies are like early experiments to see if something is even possible, which is fine. But it means we don't have a lot of solid evidence yet. The average study size was only about 30 people, which is quite small. The scientists emphasize that neurofeedback is good at changing brain activity, which is its job. But whether those brain changes actually lead to lasting improvements in behavior, how people feel, or skills they can use outside of the meditation session, that is still up in the air. A major takeaway is the huge variety in how studies are designed. They use different types of meditation, target different brain areas, and measure different outcomes. This makes it really hard to put findings together. They even point out that the definition of long-term meditator is often unclear. Some studies might call someone a long-term meditator with only 100 hours of practice, which might not be enough to see advanced meditative traits. A big problem highlighted is the control conditions. Many studies don't have a good comparison group to make sure the results aren't just from meditating alone or from the placebo effect. And sometimes, they don't even check for basic things like how breathing changes might be affecting the brain signals. Another crucial missing piece is long-term follow-up. Clinical neurofeedback usually checks in with people weeks or months later to see if any changes stick. But with meditation and neurofeedback, most studies stop right after the training, so we don't know if the effects last. They also noted that the instructions for meditation are often too general. If you don't know exactly what people were supposed to be doing during meditation, it is hard to say if the neurofeedback helped with that specific practice. And interestingly, none of the studies involved actual meditation teachers guiding the sessions. The researchers suggest that especially for novices, guidance from experienced teachers is really important, not just for instruction but for support, especially if the neurofeedback brings up intense experiences. So, what does the future hold? The authors have some really clear recommendations. First, they want to clarify neurofeedback's role. Does it actually speed up meditation learning? Can it help people get over common hurdles like anxiety or self-doubt during practice? And importantly, can it support the development of advanced meditation skills? Second, they want to standardize study designs. This means using similar methods, outcome measures, and reporting practices so that studies can be compared more easily. But at the same time, they stress the need for individual precision. Everyone is different, so neurofeedback should be tailored to the individual's brain and their unique meditation style and needs. Third, they call for more closed-loop adaptive neurofeedback systems. Think of this like a smart system that can adjust the neurofeedback in real time based on how you are doing right now, almost like a coach constantly fine-tuning your training. This could potentially model your meditation journey and adapt the feedback to help you overcome specific challenges as they arise, similar to how a teacher would guide you. And finally, and this is really important, they highlight the need to integrate ethical and existential safeguards. As we use technology to potentially speed up spiritual development, we need to make sure we're not messing with the deeper meaning, ethics, and personal growth aspects of meditation. The goal should be to augment practice responsibly, not just turn meditation into a tech-driven optimization tool. In conclusion, the research on neurofeedback and meditation is exciting and full of potential, but it is still very much in its early stages. While neurofeedback can clearly influence brain activity, we need more robust studies to see if it truly helps people become better meditators and achieve deeper states of awareness. To move forward, researchers need to be more consistent in how they design their studies, use better control groups, and be clearer about the meditation instructions. They also need to include really meaningful ways to measure not just brain activity, but how people feel and what they experience. If we can overcome these challenges, neurofeedback could become a powerful tool that bridges science, technology, and ancient meditative wisdom, offering real benefits for both mental health and the broader pursuit of human flourishing. This research reminds us that technology can indeed play a role in our inner lives. But it needs to be developed thoughtfully and with a deep respect for the practices it aims to support. What do you all think? Could neurofeedback be the next big thing in meditation, or is it just a high-tech distraction? Let me know your thoughts in the comments below, and if you enjoyed this breakdown, give this video a thumbs up, subscribe to Rubin's Mind Lab for more science deep dives, and hit that notification bell so you don't miss our next video. Thanks for watching, and I'll see you next time.